All right, these three problems today, they look a little bit tougher, but they're actually the same thing that we did yesterday. So pause the video, take some time, and see how they go for you. All right, so let's take a look at these. First one, remember you can only combine like terms that are the same letter and the same number in the exponent. So here I have a xy here, so I have to find anything else that is xy being multiplied or combined. So that's going to pair up with this one right here. So positive 10xy minus 3xy gives me 7xy. The x and the y have nothing else that they're with, so therefore we just tack them on at the end, and we can put invisible ones there if we'd like. Part F, I have x to the 8th and negative x to the 8th. Remember that's a 1 right there. So 2 minus 1 gives me just 1x to the 8th. I could, if I want, put a 1 there. It doesn't matter if I include that or not. Typically, we would not include it, but if you put it there, that's fine. And then we look at the y's. We have 7y to the 8th minus 1y to the 8th. So remember, same letters here, same numerical exponent. So 7 minus 1, since it's a negative, is 6y to the 8th. And then the last one, this one looks super challenging, but it's actually very basic. We'll see both of these are b cubed c squared, b cubed c squared, b cubed c squared. So because they're all monomials here, here, and here, right, there's nothing being adding or subtracted within it, it's just being multiplied. Because they're all the same monomial term, b cubed c squared, b cubed c squared, b cubed c squared, we just add and subtract them. So 9 plus 5 is 14. 14 minus 13 is 1. Once again, so we could put the 1 b cubed c squared there, or just b cubed c squared. All right, and subtraction. So this is the only thing that we're doing different today. And it's almost exactly like what we did, other than you have to distribute the negative 1. So we have to distribute the subtraction sign through. We're going to treat it like we're distributing a negative 1 in this problem. So this is going to get rewritten as 4x minus 8. And then we've got to distribute that negative 1. So distribute it here and distribute it here. So negative 1 times a positive 3x, negative 3x. And a negative 1 times a negative 9 gives me a positive 9. And virtually all you're doing is you are changing the signs on each one of these. So you see this 3x was positive, it's now negative. You see the 9 was negative, it's now positive. So we're distributing that negative 1. And then it's the same problem that we did in the past. 4x, a negative 3x, 4x minus 3x is going to be 1x, or just x. And then a negative 8 here, and a positive 9 make plus 1. So x plus 1 there. Same thing here. All we're doing is distributing, so I'm just going to rewrite it into a different problem. So 2x squared. Actually, feel free to pause the video here too and try this one on your own. See if you get it right. Minus 7x plus 3. I just rewrote that, and now we've got to distribute the negative 1. Distribute that through. So it's going to be a negative times a positive is a negative 4x squared. A negative times a positive is a negative 5x. And a negative times a negative is now a positive 9. So we're distributing that negative to all the parts that are there. Now let's combine like terms. 2x squared and a negative 4x squared is going to make negative 2x squared. A negative 7x and a negative 5x make negative 12x. And a positive 3 and a positive 9 make positive 12 is my final answer. Once again, we know we're done because we have different monomials here that can't be combined. Right? X squared, we can't combine that with an x, and we can't combine that with nothing at all. So just the final last 4 things here. So things to remember. First, monomials must have a number, variable, or product. No adding and subtracting of the two. So if I go back up here and I look at here, this negative 13b cubed c squared I know is a monomial because there's no adding or subtracting inside of it. A polynomial is made up of multiple monomials separated by addition and subtraction signs. Going up here, this polynomial is made up of 3 monomials, right? We've got 1, 2, 3, and they're separated by that positive, that plus sign, and this minus sign there. To add or subtract monomials, they have to have all the same variables and exponents. So once again here, we can add x to the 8 because they're both the same variable and the same exponent number. Once again, if we look at this problem, b cubed c squared, same variable and exponent number in each of these monomials. B cubed c squared, b cubed c squared, b cubed c squared. And then don't forget to distribute the negative sign when subtracting polynomials. That's what we did. That was new today. So make sure to distribute when you're subtracting monomials or polynomials.